Hi everyone, my name is Shubham, and in this video we are going to cover more than 75 plus questions on Git and GitHub. So we already know what importance does Git and GitHub plays in a developer's life and in a DevOps life, right? So it is a very important tool when it comes to version control system. We already know what actually Git and GitHub is, and if you're someone who is exploring Git and GitHub, I want you to explore the 6 hour long video that we have created on our channel. This video is in extension to that one. Here we are going to cover the basic modular questions on Git and GitHub that will give you an idea and will give you the confidence to crack the interviews, right? So grab your notepad and get ready for the question number one. I wish you all the very best with your interview journey. So yeah, let's get started. All right, so let us start with the very first question, that is, what is version control system or VCS in the very first place? A version control system is a tool that helps you to track and manage the changes made to the files or code over the time, and it allows multiple people to work together on the same project without overwriting each other's work. Okay, so basically, when we are talking about version control system, it is just making a snapshot of a single file which can be used at any reference of time, right? Now here we can just tell them there are few key points that we can keep in mind while we are dealing with VCS or version control system or source code manager. That is, first, it keeps the complete history of the changes, like who made the changes, when the changes were made, right? The email address and everything will be present. Okay, and timestamp too, that in Unix format. Okay, now next is you can roll back to the previous version if something goes wrong. So here we have something called SHA-1 hash, the commit ID that will help us to achieve this thing. Okay, third is it makes collaboration easy and safe in larger projects, because here you can ask multiple developers to work together, and like you can just ask them to collaborate in a single project. Fourth, it helps in identifying the fixes issues by tracking the file version, because that is the main thing why it gained its popularity. Let's go to the next question, that is, why do we need version control system or VCS in the very first place? We need VCS or version control system to manage, track, and collaborate on code efficiently. It acts as a time machine for your project, keeping a record of each and every change by allowing the team members to work togetherly and safely. Now here there are key points, that is, it helps you in history tracking. It keeps track of every change made by the code base, made to the code base. Second, collaboration. Multiple developers can work on the same project without conflicts. Here you can make use of branches that will help you to create a single copy of the baseline, and like you can proceed further with your development. Third is backup and recovery. Code is safe even if the files are deleted locally, because here we are pushing the code to GitHub where one more copy has been stored, right? Fourth is experimental. Basically, developers can create branches to test new ideas without breaking the main code and the baseline code, right? Because let's say if someone new joins your company and like you cannot give them the main access to the master branch, right? So here they can create a snapshot of the branches, they can create their own branches and do the further development. Now, based on that, once the approval is done, the changes will be merged, right? Okay, moving to the next one, that is documentation. Each commit includes a commit message that explains why the changes were made. So this is the exact reason why we should add meaningful commit messages whenever we are committing. Because let's say when you run git log, at that time you should understand why that commit was made and which file it is getting affected, right? So yeah. Next is synchronization. It makes easy to work from different machine by pushing and pulling the updates. Okay, so that is one of the feature offered by the VCS, or you can say Git and GitHub. All right, moving with the standard question, that is, what is the difference between SVN and Git? So SVN is called subversion and Git are both used for version control system, but they differ in terms of functionality. And you can say they are differing in managing code, or they differ in performance and collaboration. Now let's cover what are the key differences in them. So the first difference is centralized versus distribution. So SVN or subversion is centralized, where the code is stored in one central server, whereas Git is distributed, where each developer has a full copy of the repository. That is one of the first and the most important topic, first of the most important differentiator between SVN and Git. Second is in terms of performance, SVN is slower since it rely on a network connection for most of the operation. Wherever Git, it works on offline mode as well because it is faster because most of the operations happens on locally on your system. Third, branching and merging. In SVN, branching and merging can be complex and slow, but when it comes to Git, branching and merging are simple and very effective. Now, when it comes to offline working, SVN requires an active internet connection to work. So, if you lose connection, you won't be able to access your repo. But when it comes to Git, you can work offline and you can sync it later. Next is learning curve. So, SVN is easier for beginners. Git is slightly harder to learn but more powerful. But I would suggest Git is very much easier when it comes to learning. If you want to learn about what is Git and how does Git works under the hood, there is a 6-hour straight video which is created on my channel which you can refer, and it will definitely help you out to understand Git in the very first place. Whether you are a developer, whether you are into DevOps, it will definitely give you a clarity how does Git works. Alright. Moving forward in terms of popularity, that is SVN is used in older corporate environment, and right now I don't think so like any of the companies still using SVN. If you know someone, then definitely add out in the comment. And next is Git, that is it dominates over open source and modern DevOps workflow, and most of the company has adopted to Git, right? Okay, moving forward with the fourth question, that is which VCS do you prefer, Subversion or Git? If you prefer Subversion, then why? If you prefer Git, then why? So mostly I will prefer Git over SVN because it is faster, more flexible, and it is better suited for modern software development and DevOps workflow. Okay, now why I am choosing Git? So basically this is the reason that I can tell. First is distributed system. Git is a distributed version control system, so I can work offline, make commits locally, and push the changes when I'm back online. There is no network connection needed at that time. This is especially useful when you're working remotely without constant internet access. Second, it comes to branching and merging. It makes branching and merging very easy. I can create feature branches, test new ideas, and merge them effectively. This encourages clean workflow and better project organization. Third, in terms of speed, that would be most Git operations like Git commit, Git diff, Git log are local, making them Git faster than SVN, which actually heavily depends on the network access. Now, when it comes to community and ecosystem, Git has a large user base and strong community support, and that is the reason it integrates well with the tools like GitHub, GitLab, Jenkins, Bitbucket, which are very essential to DevOps. And also, in terms of ticketing, also it contains a good connection with Azure DevOps. So whenever you are making any sort of commit to a ticket, it will be directly linked, and you can actually see what commit were made against which ticket. Now, moving forward with the next one, that is history and snapshots. So Git stores an entire repository as a snapshot instead of just tracking the file. This makes it very easier for us to view and manage the project history. So, and the last one would be the popularity again, because Git has the industry standard. It is used by most of the organization and open source project, ensuring that the compatibility and collaboration is been made sure. Moving forward with the next question, the fifth one, that is what are the advantages of Git over SVN? So Git offers several advantages over SVN, making it a preferred choice for modern development and DevOps workflow. First is obviously speed. Git is faster since most of the operation, that is Git commit, Git diff, Git log, are performed locally without needing a stable internet connection. Second, you can work offline. You can commit, view history, you can create branches offline, where SVN actually require a constant connection to the central server. So, branching and merging, Git makes branching and merging very much easy, efficient, and lightweight, which is ideal for parallel development and feature testing, right? Moving forward with the next one, that is data integrity. So, Git uses SHA-1 hashing to ensure that every commit and the file change is tracked securely, preventing the data corruption. Distributed system, that is each developer has a copy of repository with complete history, and so no point of failure exists. And secondly is lightweight and efficiency. Basically, Git repository are compact to handle large project efficiently. Next is community and ecosystem. Since GitHub is a open source community, it integrates well with Git, GitLab, Jenkins, and Bitbucket. Now, moving forward with the basic question, why do we call Git a distributed version control system? So Git is called DVCS or distributed version control system because every developer has a complete copy of the repository, including its full history, and the developer can work independently without relying on the central server. Each developer can have a commit, branch, and it can merge locally without requiring the internet access. Once the changes are shared between the repository, you can just do push and pull for pushing the changes from local to central and pulling the changes from central to local. Then next is it supports collaboration so that like you can work offline, and also it offers you the fault tolerance as well. It is ideal for complex workflows in DevOps like feature branches and in release management. Now, coming up to the standard question, that is, can you explain Git's end-to-end workflow? Okay, so here it is asking from start till end, how does the Git end-to-end workflow looks like? So Git's end-to-end workflow is a structured process that allows developer to manage changes locally and collaborate efficiently with a remote repository. It ensures code integrity, supports parallel development, and simplifies the team collaboration. So here we have to explain them what are the things that you can start with the Git end-to-end workflow. So first thing would be to create a local copy, right? So the first thing would be to create a local copy of the remote repository with full history. So for that, you will have to run the command git clone followed by the repository name, repository link. Okay. Now, once you find the repository link, you will have the exact copy, and then you should go inside and do the further changes. Now here you have to edit the changes, as in make changes to the project file into your local repository, and then you have to add it into the staging area. Now, how do you add it into staging area? You will select the files and include it into the next commit using the git add command. So git add followed by the file name so that it will be added into the staging area. Next is commit. Now save the stage changes to local repository with the meaningful message. For example, git commit -n implement login feature. And then once this is done, you can create an independent branch to work on a new feature or fixes. So for creating a branch, you will run the command git branch followed by the branch name. And then in order to switch the branch, that is, you will use make of git checkout feature login branch. And once the feature is developed, you can merge the changes into the main branch. Now, how do you do it? Basically, you will integrate the changes from one branch to another by running the command git merge feature login. But before even that, you have to switch to the branch where you want to merge the changes. Now, once everything is done, every workflow is completed, you can upload the local changes to your repository so that you can share it with the world, share it with your team. So for that, you use the command git push origin main, and then once it is done, you can fetch the merge changes from the remote repository to your local to make the sync. So for that, you have the command git pull origin main that will actually do the job for you. And then let's say if you made the changes in same line in the same file, you will get the conflict. In order to resolve the conflict, you just have to make sure that you are accepting the current change or discarding the incoming based on the scenario and the complexity of the file. So resolve conflicts when multiple contributors edit the same file. Git will provide you the tool to handle it manually or with merge tools. So basically, you can make use of history inspection as well to track down the changes, view logs, and compare the different commits. Okay, if you want to see the logs, you can run the command git log, and if you want to compare two commits, you can run the command git diff followed by commit 1 and then commit 2. It will tell you the actual diff between the files, between the commits. And next is remote collaboration. It enables team members to collaborate seamlessly by pushing and pulling the changes from a shared repository, supporting CI/CD workflow. And the real world example would be in DevOps pipeline, developer create feature branch for new development and commit them for testing it locally. They push the changes and then they create a PR, that is pull request, to merge it into the main branch for automated build and deployment. Okay. Next, how do you clone a code using Git? So basically, they have the command called git clone that will do the job. So cloning a Git repository meaning creating a local copy of the remote repository, including its entire history, so that you can work on it locally. Now, what you can make use of? So you can make use of git clone followed by the repository URL. So cloning mean downloading all the file, branches and commit history that will help you to get started with your current development. And after cloning, you can edit, commit and push the changes to the remote repository. So here is the command snippet that you can see: git clone followed by the repository link, so that it will clone and create a copy of the remote repository into your local. Okay, so you just have to open your terminal, run the git clone command and the repository URL, press enter, and the local copy for your development will be created in your current directory. Okay. Now, what is the difference between commit and push? Okay, so in Git, commit and push are two different actions that are handled to make the changes locally, and then you can push the changes remotely. So what is commit? Commit save your changes to a local repository. It acts as a snapshot creator for your project at that point in time, and it helps you to track and roll back if needed. Whereas push uploads your committed changes from local repository, okay, to your remote repository, and it makes your update visible to other for the collaboration. Okay, so the command that would be used for pushing would be git push origin main. Okay, what would be the real world example for this? Let's say a developer commits a code multiple times during the development for local save, and then push it at the end of the day so that it shares the update to the team on the remote repository. So in short, commit meaning local save and push meaning to share it to the world. Let's come to the 10th question, that is, what is the difference between push and pull? So in Git, push and pull are again two different commands that are used for synchronization of the changes to your local and remote repository. Now what does push does? Push will send your local commits to remote repository, that is GitHub or GitLab or Bitbucket, and it is used to share updates or backup the work. For example, after committing the code locally, you will push it to GitHub so that the team can access it. Now, when it comes to pull, it will fetch the remote changes, okay, and merge them into your local branch. It keeps your local copy up to date with others' work. So when you are done with pushing your changes, someone will have to push it. Someone will have to pull it, right? So that can be done with the use of git pull command, and the command that would be used over here would be git pull origin main, where we are pulling the changes specific to the main branch. So here, example would be before even starting new work, you pull the latest changes made by the teammate so that you are up to date with the current code base, and then you can proceed forward with the current development of your feature. In short, push will send your changes out. When we say out, from your local to your remote, and pull will be to get others changes in, basically from remote to your local. All right. Now coming up to the standard question, that is, can you explain Git architecture? So Git's architecture is built around three main stages or area: the working directory, the staging area or the indexing area, and the Git repository. The structure follows and allows you for flexible and control version system management. So let's say there are three key points that we need to keep in mind: working directory, staging area or index area, or Git repository. So when we say working directory, this is where you make the changes to your file, and it's your local workspace. When it comes to staging area or index area, it is a temporary area where you make the changes before committing them, and you choose which changes to include them into your next commit. Next is Git repository. This is where the Git stores the changes permanently for your project. It contains the commit history for and other metadata. Now, when we say other metadata, meaning who made the changes, when the changes were made, what is the email address, what is the timestamp, and related information. Here, there are key concepts that we are covering, that is commit. Basically, what is commit? Commit is a snapshot of your project at that specific point in time. Each project, each commit has a unique ID. Branches. So branches is an independent line of development that allows you to work on features without affecting the main code base. Remote repository. So it is a copy of your repository hosted on server like GitHub for collaboration, and it can also act as a backup for your code. Next would be clone, to create a local copy of a remote server of a remote repository. Pull, to fetch and merge the changes from remote repository to your local copy, and push would be to send your local commits to the remote repository. So in essence, Git architecture ensures you that you have a complete history of your project, and you can work on different features simultaneously and collaborate effectively with others. Moving forward with the 12th one, that is what is the main difference between centralized version control system, CVCS, and distributed version control system, that is DVCS. So the main difference between centralized version control system, CVCS, and distributed affecting the collaboration and workflow. So let us cover the key differences between CVCS and DVCS. So let's cover CVCS first, that is centralized version control system. So first is storage. So the code is stored in a single central server. The workflow, basically developers check out the file, work on them, commit the changes back to the central server. And third, in terms of connectivity, it requires a constant connection to the central server for most of the operation. Fourth would be single point of failure. So if the central server goes down, all the work is disrupted. So basically here the example would be SVN, that is version, and secondly is CVS, okay, centralized version control system. Now let us go forward with the distributed version control system, that is Git and GitHub and GitLab and Bitbucket. So basically here the first thing would be storage. Each developer has a complete copy of the entire repository, including its full history on the local machine. Second is workflow. Developer commit changes to the local repository and then push or pull the changes from a local to remote repository. Okay. Third, in terms of connectivity, so you can work offline without even needing a internet connection. So no constant connection required to a central server. You can work remotely without even requiring the internet connection. The next is redundancy. So multiple remote repository can exist, reducing the risk of single point in failure. So if something goes wrong, you definitely have a copy in local. You definitely have a copy in your fellow developers' machine. So like if something goes wrong, you definitely have a copy. The example here is Git and Mercurial. Next is 13, that is how do you create a Git remote repository. The remote repository is typically hosted on a GitHub platform like GitHub or GitLab or Bitbucket, and it serves as a central place for teams for collaborating or storing their code. So here there are few key concepts that we can keep in mind. First is choosing a host platform such as GitHub, Bitbucket, or GitLab. Secondly, to create a new repository on your chosen platform, you have to follow the instruction to creating a new repository or an empty repository. So you'll be asked for the name, description, and visibility. So when it comes to visibility, basically it can be public or private. So when it is a public repository, it can be accessed with anyone. And when it is a private repository, only the people who have the access can access the repository. Now get the remote URL. So after the creation is done, the platform will provide you with the URL, that is HTTP or SSH for your new remote repository. Then next is a link to remote repository. Now in your local Git repository, you use the command that is git remote add command to link it to your remote repository. Now let's say your senior developer is not present and you have to start with your working. So at that time you cannot stop your work, right? So at that time what you can do is basically you can create a repository in your local and then you can link it with the remote repository after he is back. Now for that we have command called git remote add, and it will actually link your remote repository with your current local one. Next is push initial code. So basically you can push your local code to the newly linked repository using the git push command. So basically in short, you can create on a platform, get the URL link, and it can create a local copy and push your code. All right, moving forward with the next question, that is what happens if you delete the .git folder in your Git repository. So this is a standard question and something that is coming out of experience. So if you delete the .git folder, what would happen? You will actually lose entire thing. So if you delete the .git folder from Git repository, you will effectively remove the entire Git version control system from that repository. This means the folder will no longer be a Git repository. It will act as a normal folder in your desktop. Okay, so what can be the consequences? The first thing would be you will be losing the track of history. Okay, you will lose the track of branches, tags, and any other version control information. So there would be no version control. Basically, the project will no longer be tracked by Git, meaning you cannot commit a new changes, switch branch, or revert to the previous version. There would be no remote connection. Basically the remote, you won't be able to link any remote repositories like GitHub, and the link will be broken. So files remain, the actual project file will remain, but they will be just a regular file without any version control capabilities. In short, they will lose their powers for the version control. Deleting .git will turn your version control project into a regular folder, losing all its history and Git functionalities. Okay. Now, how do you configure your username, email, and editor in Git for the very first time? So basically, this is the first level configuration which we do. Basically, when you're starting with Git, it is very important to configure your username, email, and the preferred text editor. So this information is attached to your commits, helping to identify who made the changes and what changes were made. So basically, there are few commands, that is set username, set email, and set editor. So here you have the command called git config --- global user dot name, git config --- global user dot email, and that is how you will provide the username and email to the Git for the very first time, and that would be very much easier for Git to understand. So the --- global flag means that the settings to apply to all your Git repository, and these settings are crucial for proper commit, abbreviation, and workflow. Okay, next is where does Git store the configuration details? Okay, so Git stores the configuration details in specific files which can be global for all your projects or local for a single project. That is a global configuration which is stored in .git config. It is a file in your user's home directory, that is /.git config. This settings apply to all your Git repository. Second configuration is local configuration, which is stored in .git/config. Which is a file which is stored with a specific Git repository. These settings only apply to that specific particular repository and can override the global settings if there is a conflict. Okay, so the key points here would be you can view and edit this configuration file using the git config command. Secondly, understanding this location help you to manage different settings over various projects. Next is what is the advantage of staging area or indexed area in Git. So see, the staging area is also known as index area, as I mentioned earlier. It is unique feature in Git that provide you a flexible way to prepare your changes before committing them, and it acts as a middle ground between your working directory and your remote repository. And let's cover the key advantages of it. So the first would be selective committing. You can choose exactly which changes, even the part of the file, to include in your next commit rather than committing all the modification at once. Okay, so you can make use of git add dot for including all the files, or for adding this specific file, you can just write git add followed by the file name which you want to move into the staging area. Second is organized commit. So this allows you to create small, focused, and logical commits, making your project history cleaner and easier to understand. Third would be review and test. You can use the staging area to review and test the set of changes before making them a permanent part of your project history. Then fourth would be undo stage. So if you accidentally stage a file, you can easily unstage it without losing your changes in the working directory. So in short, the staging area gives you the fine-grained control over what goes into each commit, leading more organized and manageable project history. Alright, so what are the common git log options? So git log is the command used to see the project history. So it has many options to customize its output. So it helps you to find specific commit or display the history in different ways. So those are the following options that we are going to see. So the first one is -one line. So it will show each commit into a single line, and it will display all the shortened SHA-1 hash and the commit messages. Okay. Second is git log -author followed by the author name. So it will filter the log and it will only show the commits made by the specific person. Now, if you want to see, if you want to filter it with the date, so you can write git log -fm since followed by the date and until. So from and where. So this will act as a filter. It will filter it by the commit date, showing the commits made after, since, and before, until, before the specific date. After and before changes can be made use of since and until. Next is graph for searching it with the pattern in the commit. So let's say if you are using Azure DevOps, you will write AB hash, and then based on those pattern, it will give you all the commits. So it will search the commit with specific message pattern. Next is git log -fn graph. So basically it will display the text-based graphical representation of commit history, useful for visualizing branches and merges. Next is the regular log option that I use more frequently, that is git log hyphen pretty equals to format, followed by the format string. Now that can be %# for hash, %an for author name, and %s for subject. So it will allow you for custom formatting for the log output using the placeholder. Okay. So in short, git log help you for efficiently navigating and understanding the project history by filtering and formatting the output. Coming up to the main question, that is what is SHA-1 hash in GitHub, right? All right. SHA-1, that is secure hash algorithm, or SHA-1, is a cryptographic hash function that Git uses to generate unique identifiers for every piece of data it stores. Now, these identifiers are actually crucial for maintaining the data integrity and tracking the changes. Now, what are the key points over here? First is unique identifiers. So, every Git object, that is, it can be a commit, tree, blob, or tag, it is given a unique 40 character SHA-1 hash. Okay. Now, data integrity. So, even if a single bit of data changes, the SHA-1 hash will completely be different, and ensuring that no data has been corrected or tampered. So, when I say even if you add a single space, a new SHA-1 hash will be generated and you will get a new copy of your project. Object addressing. So Git uses these SHA-1 hash to refer them with specific version of your files and commit, so that other objects within the repository. Git uses the SHA-1 hash to refer the specific version of the file, commit, and other objects within the repository. Now, fourth one would be the immutability. So once the object is created in its SHA-1 hash is generated, it cannot be changed without generating a new hash. So this is actually helping Git history to be more secure. All right. So in short, SHA-1 hash is a fingerprint system in Git, ensuring that every piece in the project history is unique and verifiable. Question number 20, that is, how do you show the content difference, that is git diff, of a modified file in your working directory? So whenever this question has been asked, we are targeting to the command of git diff. Here difference is the keyword for us. So to see the changes you have made in your files in your working directory that haven't been staged yet, you can use the git diff command. This command allows you to find the differences between your current changes and the last committed version. So the command that you would use is git diff. Now here, there are a few key points. This command shows that the changes are not yet staged. It compares the files in your working directory with the files in your staging area, or the last committed file in the staging area, which is empty. So the output highlights additionally usually starts with plus, and the deletion is highlighted with minus in your code. So in short, git diff helps you to review your unstaged changes before deciding them to add them into the staging area. So it is a handy command which we use more oftenly. Now, question number 21, that is, how do you show the content differences of file that is staged? Now see, again here the keyword is different. So here we would be talking about diff. So to see the changes that you have moved into staging area using the git add but haven't committed yet, you can make use of git diff -- stage command. This will help you to review what will be the included in your next commits. Now here there are a few key points. This command shows that the changes are staged but not yet committed. Second, it compares the file in your staging area with the last committed version in your local repository. Third, the output clearly indicates the additions and deletions, allowing for final review before committing. So in short, git diff -- stage is an essential for verifying the exact changes that are prepared for your commit for the next version. Question 22, how do you delete a file in Git? Okay, so to delete a file from Git repository and also from your working directory, you use the command git rm. Okay, this command stages the deletion. So still you need it to commit it. So basically every operation that you do, basically addition, deletion, even if you add a space, it will create a new ID. It will create a new SHA-1 hash. So here, even if you delete a file, it will create a new SHA-1 hash. So git rm followed by the file name. This command removes the file from your working directory and stage the deletion. After running git rm, you will need to commit the changes to make the deletion permanent in your repository history. Now, the third and the important point here is if you only want to remove a file from Git tracking, but you want to keep it in your working directory, here you can make use of git rm cached followed by the file name. So in short, git rm is the way to tell Git that you want to stop tracking and remove the file from the project. Okay. Now, next is how do you rename a file in Git? So to rename a file in Git, you use the command git mv. Okay, this command not only renames the file in your working directory but also stages the changes, making it ready for your next commit. So basically, how would the command look like? So it is actually git mv followed by the old file name and the new file name. Here there are few points for the consideration. The first one would be this command renames the file in your file system and stages them with the rename operation. Second, after running git mv, you will need to commit the changes to record the file name change in your repository history. Third, it is basically essential for adding a shortcut. So basically mv old file with the new file. It can be replaced with git rm old file with the new file. So in Linux, we have a command called mv that does two operations. First, it is used for moving a file, and secondly, it can be used for renaming a file. So likewise, the same way we have git mv command that actually helps to rename the file with the old one with a new one. So next is which branching model is popular for parallel development. So for parallel development, a very popular and structured branching model is the Git Workflow. It uses multiple dedicated branches for different stages of development. So it ensures clear and organized process. So there are few key aspects that we need to follow in Git flow. First is the main branch. It can be main branch or it can be a master branch. So main branch holds the official release history. So it is considered as one of the stable branches because it is the place where all the development is done, all the testing done by the QA has been approved, and it is ready for the production deployment. That is the reason it is holding the official release history. Second, develop branch. So most vulnerable branch, most experimented branch. It integrates all the completed feature and it serves as the main branch in the development pipeline for the developers. So whatever new things comes, it comes into the development branch. So if you want to see in terms of version, if master branch is on version 2, development branch will be on higher version definitely because that is the branch which has been updated very regularly. Okay, so here there can be few supporting branch between development and master. The first would be the feature branch. So it is created from the development branch for new feature or changes, and it is merged back into development once the feature development is completed. Release branch. So it is created from development again to prepare for new releases, allowing for the bug fixes and the final touches. So it is merged into both master and development branch once the things are ready and it is actually accepted by the QA. So when it comes to feature branches, it is actually owned by the developer itself. When it comes to release branch, it is merged based on the approval by the QA team. Next is hotfix branch. So it is created from the masters directly to address the critical bugs in the production, and it is merged back both into master and development. Now why we have to merge into development? Now let's say if you gave the hotfix and after giving that hotfix something else is getting break, right? So in order to address the same thing, we are merging into development so that whenever the QA is running the regression, whenever the QA is doing the smoke test, it can be catch up by the QA team and they can actually help us to address it in the next release. So that is the reason why hotfix branch is given most priority when it comes to the development workflow. Now, what are the key points? So, Git Workflow provides a robust framework for managing large projects with frequency of releases. It helps to in maintaining a clean repository, a clean history, and separates the ongoing development from the release preparation because here we are maintaining multiple branches. Okay, so the master branch is the production branch which is deployed to the customer instance. The development branch which is actually updated by the development team on a regular basis so that whatever new things are going on, it is actually updated there. Okay, release branch. So now once the development is done, once the feature is merged into development, the integration testing is done, then it goes to the QA for the approval and then it is merged into release and the release has been done. So in short, Git flow is a structured branching model that uses specific branch for feature releases and hotfixes to enable efficient parallel development. Now, how do you take a bug fix to production? Okay, taking a bug fix to production involves a structured process ensuring the fix is correctly implemented, tested, and deployed without introducing new issues. Okay, This typically follows a well-defined release workflow. So what are the key steps over here? First, fix and commit. So the developer will identify the bug, implement the fix, and commit the changes to an appropriate branch. Now it can be a dedicated bug fix branch or a development branch. Second is testing. The bug fix undergoes through testing. So there can be multiple round of testing that can be done. Unit test, integration test, regression test. So why this testing has been done? So basically it is used to ensure that it resolves all the issue and it doesn't create new problem. That is the main reason why testing is so important in its development workflow. Third is code review. So the code are reviewed by other team members to ensure that the code quality and the adherence to the standards and the compliance have been met. Then next, the fourth one, that is merge. So once the changes are approved and tested, the bug fix branch is merged into the main branch and the development branch, and then potentially into a release branch or directly to the production branch. So depending upon the branching strategy. Now, a branching strategy can differ company to company, organization to organization, based upon the team side and the bandwidth of the team. Okay, now deployment. So the updated code including the bug fix is then deployed to the production environment. It oftenly involves an automated CI/CD pipeline. So if you want to learn about CI/CD pipeline, we are currently running a Jenkins playlist where you can actually learn what actually Jenkins is, what is an automation workflow, and how does we can perform an CI/CD. So those things can be done in the Jenkins playlist. So link you will find in the description itself. Next is monitoring. So after the deployment is done, the production environment is actually monitored to confirm that the bug is actually resolved and no new issues has been arising. So that is the reason monitoring plays an important role. So in short, fixing a bug for production involves coding, rigorous testing, code review, merging, deployment, and post-deployment monitoring. Next, 26, that is what are some different branching models used in software development. So various branching models are used in software development to manage code changes, which facilitate collaboration and streamline release processes. Each model has its own set of rules and conventions. So let us cover a few common branching models. So the first model here would be the Git flow work model. So it is a highly structured model with the dedicated branches of feature, releases, hotfixes, and main development. So here we have main development master for idle projects with scheduled release. Now, second is GitHub Workflow. So it is a simpler, lightweight model centered around the main branch. Features are developed in branches, merged into main via pull request, and main is always deployable because it is the production facing one. GitLab Flow. So it is an extension to GitHub Flow that adds environment specific branch, that is production branch, pre-prod environment for continuous delivery. Okay. Next is feature branching. So developers create a new branch for each new feature or bug fixes, keeping the main branch stable. Once complete, the feature is actually merged back to the branches. Release branching. So it is used to prepare for new software releases, allowing the bug fixes and final testing without affecting the ongoing development. Mainline development, that is trunk based development. So all the developers commit directly to the single main branch with very short lived feature branches which require strong testing and continuous development. However, mainline development is actually avoided because it is the only branch that is customer facing. You cannot directly merge the changes into main branch. That's the reason mainline development or trunk based development is been avoided. So in short, branching model provides strategies for managing the code changes and collaboration, ranging from simple to highly structured processes depending on the project needs. Okay, now again it depends upon organization and again it depends upon the team size. Based on that, you define your own workflow. Now, can you explain the merging process in Git? The merging process in Git is how you integrate the changes from one branch to another. It combines the history and content of the difference of lines into a single one. So basically, it is called a unified branching strategy. So basically, two branch is been present and you are merging them. So that is actually it is asking for. Now here there are few key steps that we are targeting. First is switching the target branch. So the first thing that you have to do is first you will switch the branch where you want to incorporate the changes. It can be a main branch. It can be a development branch. Second, merge the source branch. Then you use git merge command to specify you want to merge from. Third is if there is any conflict, Git cannot automatically combine it. It will need human intervention in between. So the same line will be modified with different person in different branches. So a merge conflict will occur. Git doesn't know which code to take care of. That is the reason a software engineer's intervention is needed. So to solve the merge conflict, you will need a software developer. Now, once you do it, it will be a manual activity to solve this conflict, and the affected line will be incorporated based on the decision made. Last would be the commit. After a successful merge, either automated or after resolving the conflict, Git will create a new commit merge that records the integration of two branches. Now, as mentioned earlier, for everything, whatever you do in Git, there is always a SHA-1 hash created. And this time, even for merging, you have a merge commit created. So, here the key point is merging preserves the full history of both the branches. Now, 20th question, that is, how do you merge a code in Git? To merge a code in Git, you make use of git merge command. This command integrates the changes from specified source branch into a current active branch. Okay, so basically the command used here is git merge followed by the branch name. So the first thing that you want to do over here is you will first ensure that you are on the branch where you want to receive the changes. It can be development branch, it can be main branch. Now, second is once you are switched into the target branch, you will merge the changes by running the git merge command. It will specify the name of the branch you want to merge into your current branch. Now, if there is a conflict, so if Git encounters conflict, you will need to manually resolve it before even merging to get completed. Now, once the conflicts are resolved, then only you can merge. And after a successful merge, Git automatically creates a merge commit unless it is a fast forward merge to record the integration. In short, git merge is a command to combine the changes from one branch to another, bringing different lines of development together. Now, what is a merge in Git? Now, another way to answer it, in Git, a merge is a process of integrating changes from one development branch into another. It combines the history and content changes from source branch to the target branch. So here we are talking about integration, history preservance, conflict handling, and type of merges. So basically, integration, it brings together the divergent line of changes into development. History, it creates a new commit, a merge commit that records the act of combining two branches by preserving history of both. Third, conflict handling is changes in both branches overlap in a conflict. Git will pause the merge and allow you to manually resolve this conflict. In short, Git merge is a way to combine different streams of work into a unified project. Now, what is a conflict? Now, same line, same file. So basically, how you answer it, that is something which is repeated over here. A conflict in Git happens when you try to merge or rebase your branches, and Git cannot automatically combine the changes before the same line of the code is been added. So here, it will say that, okay, the file is being changed. Now we change to take care of. So here, the changes has been modified indifferently in different branches, and then it has been merged. Okay, so basically when two files from two branches is been affected, it will add the markers. Now, based on their marker, you will make sure which one to take and which one to delete, which one to eliminate. So Git will typically show you the markers. If you can see, these are the markers which are currently present. So these markers are added in the file to highlight the conflicting section. So in short, a Git conflict is a situation where Git needs your help to decide which one to combine and which one to discard from different branches. Now, what is a fast forward merge in Git? All the changes were made directly to the target branch. Third, condition. So a fast forward merge is possible only if the current branch is directly ancestor of the branch being merged. Let's take an example. If you create a feature from main and you make the commit from feature branch and main, it has no new commits. Merging from the feature branch into the main will create a fast forward merge. A fast forward merge is a straightforward merge integration where Git just update the branch pointer, resulting the linear project history without even a new merge commit. All right, moving forward with the next question, that is, what are the main differences between Git merge and Git rebase? So both Git merge and Git rebase are used to integrate changes from one branch into the another, but they do so in fundamentally different ways, impacting the project's commit history. Now let us compare the key differences for both Git merge and Git rebase. So Git merge, so here history it and second is commit graph, results into a non-linear branching commit history, which can be seen as a more accurate representation of what actually happened. Third, safety, generally considered safer for shared branches because it doesn't rewrite the history. So, what could be the use case? So, it is best for the integrating feature branches into a long-lived shared branches like main or develop, where preserving the history is very important for us. Now, when we can make use of Git rebase, so it will rewrite the complete history of the source branch. It moves or reapplies the commit of your feature branch into the tape of another branch, making it appear as if you have developed your feature directly from that point. Okay, here the commit graph. So it creates a linear commit history, which make the project history look cleaner and easier to follow. That is safety. It can be dangerous on shared branches because it rewrites the history, potentially causing the conflicts for collaborators. What can be the use case? So often used to keep the feature branch up to date with main branch before merging, or to clean up the local branch history before pushing. So in short, merge preserve the history with a merge commit, while rebase rewrites the history for a cleaner linear look. So you have to choose wisely on your team's workflow whether the branch is shared. So whether you want to merge to preserve the history, or whether you want to rebase to rewrite the history. Okay. Now, how do you resolve conflict in Git? Okay, so again the question is repeated. So resolving conflict in Git is a common task when merging or rebasing the branch. It involves manually intervention to tell Git how to combine the conflicting changes. So here you have to identify the conflict. So Git will notify you the conflict during the merge conflict. It will stop the merge process. You can see the files which are conflicted using the Git status. Secondly, when you open the conflicted file, you will see the markers which are used for the identification for the conflicting section. Then you have to manually carefully review the conflicting code from both the branches and then manually combine the changes as desired, because Git cannot take that decision. You must remove all the conflicting markers. Okay. Now, once everything is done, you will save the modified file after resolving the conflict. Now, after the conflict is resolved, you have to stage them. So you have to tell that Git that the file conflict is being resolved, and then I am just adding it into the staging area by again using the command git add followed by the conflicting file name. And then once it is into staging area, then you have to commit it. So complete the merge or rebase by creating a new commit for merges, or for continuing the rebase by using the command git commit, or if you are using a rebase, so git rebase hyphen continue for rebasing the process. So in short, resolving conflict means manually editing the file or combining the conflicting changes and then staging and committing their resolutions. Next is, what kinds of conflict do you encounter in Git? So Git conflict can arise in various scenarios when merging or rebasing branches, especially when the changes overlap. So understanding the types of conflicts helps you to resolving them effectively. So the first is content conflict. So this is the most common type, and it occurring when the same lines of the code in the file are modified in two different branches. Git cannot decide which version to give. Second is a renaming conflict. So it happens when the file name is renamed in one branch, but its content is modified in another branch, or it's deleted in another branch. Third is delete conflict. So it occurs when a file is deleted in one branch but modified in another branch. So Git needs to know whether to keep this modified file or it can proceed with the deletion. Last one would be the tree conflict. So it is more complex conflict that involve changes into the directory structure, such as moving or deleting directories that contains modified file. So in short, Git conflicts are not just about conflicting line of code. They can also involve file rename, deletion, and structural changes, and all requiring the manual resolution. So conflict is something that cannot be resolved by Git itself. It is something that requires human intervention in between. Moving forward with the next question, that is, who is responsible for resolving the conflict in Git? Okay. So generally it is the developer who initiates the merge or rebase process and is actually responsible for resolving the conflict in that arise. Okay. This is because they are trying to integrate their changes into the current branch, and they should understand both the sets of modification what they are making. Okay. So the key points: individual responsibility. So when you pull, merge, or rebase, and if you encounter conflict, it is your responsibility as a developer to resolve them on your local machine. Now, team collaboration: if in a team sitting, if conflict arise during a pull request or a shared merge, the developer whose changes are conflicting often to collaborate to resolve the issues. So basically, you are supposed to actually resolve it, add a commit, and then it would be a team collaboration that you would be doing. So the person performing the merge conflict is actually typically who facilitate it. Third is understanding the changes. The person resolving the conflict needs to have a understanding the intent behind both the set of the changes to make informed decision about how to combine them correctly. In short, the developer performing the merge or rebase is primary responsible for conflict resolution, often with collaboration from other team members if their changes are involved. So let's consider if two developers are involved and you are overlapping his changes, then either the person two should be informed what changes are doing, because there might be a possibility that the other person changes are actually needed and also yours. So that is how you can do a team collaboration, and you can come up to a decision which changes to keep and which one to discard. All right. What is the main difference between a branch and a tag in Git? So in Git, both branch and tag are used for marking specific pointers in your project history, but these are fundamental different purposes related to the development and releases. So let us see the key differences between branch and tag. So branch, the purpose represent an ongoing development, and it is acting as a pointer to the latest commit in the sequence of changes. Branches, so branches are evolutionary. So branches are designed to move forward as new commits are added, and they are dynamic. So what can be the use case? So it is used for developing new feature, fixing bugs, or experimenting new ideas without affecting the main branch. Okay. Tag. So what is the purpose? So purpose is it is acting as a static marker for a specific point in history. It is like a permanent label on a particular commit. Tags are fixed and it does not move. It is only created once and they always point to a specific commit. It is used to mark a specific release, or a significant milestone, or the stable version of your project. In short, branches are for active development and evolution, while the tags are related to static labels. They are more into historical pointers, or specifically pointing the stable releases. When do you create a branch versus when do you create a tag in Git? So the decision of creating a branch or a tag depends upon your purpose. Branches are for active evolving development, while tags are used for marking specific points in history. So when to create a branch? So when you are starting on a new feature, create a bug branch associated to the development from the code base. Secondly, bug fixes. So when you are fixing the bug, especially if it requires complex or multiple changes, so at that time you created a branch. Experimentation. So branches can be created for experimentation. So when you want to try multiple new approaches for without impacting the stable code, or branches can be created for parallel development. So when multiple development need to work on the same aspect of the project simultaneously, you can create a branch. Now covering up the topic, that is when to create a tag. So basically it is used to mark the specific point in history in the specific commit. So it is used to mark a specific version of your software that is being released. Second is milestone. It is used to highlight the important project milestone or checkpoints. Third, stable points. It is used to provide a permanent unchangeable reference to know as a good state of the code base. In short, we can use branches for ongoing work that changes and evolve over time, and tags are used for permanent static markers for point in time references, just like releases. How do you create a branch and switch it into a single command? So see, effectively create a new branch and immediately switch into it, Git provides a convenient shortcut using the command called git checkout. with command -b flag. So git checkout -b followed by the branch name. So what it will do, this command perform two actions at the backend. The first thing would be it will create a new branch with the specified name, and then it will switch to your working directory to that specific new branch. It is equivalent to running two commands, that is git branch followed by the branch name for creating a new branch, followed by git checkout hyphen followed by the new branch name. So it is running two commands at the backend, that is git branch and git checkout. This is commonly used when you are starting work on a new feature or bug fix, allowing you to quickly isolate your changes. So in short, git checkout -b is a quick way to create and switch to a new branch, streamlining to your workflow. Question number 39, that is, what is head pointer in Git? Okay, it is an important question. So the head pointer in Git is a crucial reference that points to the latest commit into your current branch. It is essentially telling you that where you are in the project history and what commit you are working on the specific pointer based on it. What are the key points? So basically current commit. So head always points to the snapshot of your history, snapshot of your project that is currently checked out into current working directory. Branch reference. So typically head points to the tip of the branch. Example reference /head mean. When you switch the branch, the head will move the pointer to the latest commit of the new branch. That is detached head. So it is possible for the head to point directly to a specific commit rather than to a branch. So this is called a detached head. It means you are not on any branch, which means which can be useful for inspecting old commits, but not for making new changes that you want to keep easily. Location. So the head can be used for head as in pointer. It is stored in .git/head with the file in your Git repository. So that is the location .git/head where you will find the header information. So head in Git is a way for knowing your current position in the project commit history, which is usually indicating the tip of your active branch. Now, how you can store binary files in Git? So yes, you can store binary files in Git, but it comes with important consideration, especially regarding the repository size and performance. So Git is primarily designed for tracking the changes based on text-based file. So first is technical capability. So Git can technically store any type of file, including the binary files like images, videos, audios, or compiled executables. Second, performance impact. Large binary files can significantly increase the size of your Git repository. This can lead to slower cloning, fetching, and pushing operations for all the collaboration. Third is delta comparison. So Git stores deltas, that is differences, for two text files efficiently. For binary files, however, changes often result in storing entire new version, which is a little less efficient. So recommend solution that would be Git LFS for managing large binary files. So what is LFS? LFS is large file storage. So basically it is highly recommended to use Git large file storage, that is LFS, which replaces the large file in your repository with a text pointer while storing the actual contents on a remote server. So in short, while Git can store binary file, it is best practice to use tools like Git LFS for large files to maintain repository performance and for maintaining the manageability. Now, how you can skip the stage area and commit changes directly. So while staging is a powerful feature for fine-grained control, Git allows you to skip the stage area and commit all the tracked, modified, and deleted change directly to the directly using the -a or -all flag within the Git command. So here you have the command called git commit -a-m followed by the commit message. All right. So what are the things that it will do? This command will automatically stage all the changes to the files that Git already tracks. That is a file that have been added to the repository previously. It then creates a new commit with these stages changes and provide a new commit message. Second, it is important that this command will not stage new untracked file. You will only need to use it git add for those. It's a convenient shortcut for quickly committing all the current modification to track the file. So in short, git commit -a lets you bypass the git add step, and it is used for already tracked file, making a quicker commit workflow. All right, so let us move forward with the next one, that is how do you list the files or folders modified as a part of specific commit. So to see which files or folders were changed in a particular commit, you can use the git show command combined with hyphen hyphen name or hyphen hyphen name status flag. So git show hyphen hyphen name only followed by the SHA-1 hash. So you have to replace the commit SHA with the unique SHA-1 hash of your commit that you want to inspect, and you can find it using the git log command. Okay, hyphen hyphen name only, it will shows only the name of the file that were modified, and a hyphen status will show the name of the file along with the state. So A for added, M for modified, and D for deleted. So if you omit SHA, and git show will display the changes for the latest commit. So in short, git show will is an git show with appropriate flags help you to identify which files were affected during the specific commit. Now, what is git revert? So, git revert is a command used to undo the changes introduced by a previous commit. So, instead of removing the commit history, it creates a new commit that applies to the inverse of the changes of the specific commit. It is a non-destructive. Unlike reset, git revert does not rewrite history. It creates a new commit, making it safe to use on shared branches. So, under changes, so the new commit effectively cancels out the change made in the original commit. It will preserve the history. The original commit remains in the project history along with the new revert commit, providing a clear audit trail. So what is the use case? So ideal for undoing the changes that already have been pushed into the repository, and it avoids disruption collaborators history. So the command is git revert followed by the SHA-1 hash. So in short, git revert safely undoes the changes by creating a new commit that reverses the previous one by preserving the project history. Now, how do you create an git ignore list that applies to all users? A global git ignore. So to ensure that certain files or pattern are ignored across all the Git repository, you can set up global file that is .git ignore. This is used for ignoring OS specific files, editor configuration, or personal temporary files. So the key concept here is configuring global exclude file. So you need to tell where your global file is located using git config command. Second, create and edit the file. So create the file name .git ignore and add the patterns of the files or directory that you want to ignore globally. So here you can add the patterns in the .ignore file to apply all the changes in your Git repository. This file is separated from the .ignore where individual repository is been stored, which is used for specific project, and it will ignore all the files which you mentioned over there. So in short, when you explicitly tell .git ignore hyphen global, it will be common for all the files stored within your local repository, local system, and it won't push those files. All right, so that is the basically use of .git ignore. So if you want to exclude few files from being committed, you just enter the files and folder name on .git ignore, and it will actually not committed. Now, 45th question, that is, what files and folders do you commonly ignore in a project, and what are some of the common patterns for .git ignore? Since mostly software project, there are certain files and folders that should not be tracked by Git because these are generated during the build process and contain sensitive information or are in a specific developer's local environment. So these are the typical listed .git ignore files. First is build artifact, that is .class, .o, .exe or target build. Second is dependency such as node underscore modules or vendor or .venv. Third are log temporary files, that is .log, .tmp. Configuration file like .env, .config, .local.js, or IDE specific file, that is .idea, .vs code, .ds underscore score, or thumbs.db. So these are the few of the files that we usually ignore during in a .git ignore file. So if you want to see a .git ignore file, so this is a sample file where you can see all the files and folders which have been added. So operating level system files are thumbs.db, .ds underscore store, artifact level file, that is .exe, .class. So it will add all those things which are present here, and it won't be allowing the developer to commit this file. Also, you can add a dependency file like node underscore modules, vendor, or venv. You can also add .log.tmp in the .ignore file so that you won't be allowing the developer to push it into the repository. So in short, Ignoring unnecessary files keeps your repository clean, reduces its size, and prevent conflict related to local and generated content. Now, how do you remove a committed change in Git? So, removing a committed change in Git depends upon whether the committed change has been shared with others. When I say others, it is like whether it is pushed to the remote repository or it is still in local. So, this approach changes to is a change to avoid disrupting collaborator. So there are key methods that you can do, that is Git reward, which is recommended for shared history. When I say shared history, meaning like it is a specific branch that is being used by multiple developers. So what it will do, it will create a new commit that will undo the change of the previous commit. It is a non-destructive command, so it doesn't rewrite the history. It is making safe for the commit that already been pushed to the remote repository. It will add one more reward commit so that the person who is going to make a pull, it will have the latest changes. So when you have to use it, you need to undo a change that other might already have in their local. At that time, you make use of git revert. Okay. Now git reset it moves the pointer to the earlier commit, but it will remove entire thing. Okay. It is a destructive command. It will rewrite the history. So it should only be used for the commit that you have pushed to the shared repository, that you have not pushed to the shared repository, which is present in your local. So when you should use it, you want to complete erase a commit from your local history. That's where you use git reset. Now, what is Git Reset -I? It is interactive reset for local history cleanup. So it allows you to interactively reorder, squash, edit, or drop commit. It is destructive. It is rewriting your history. So use it with caution on shared branches. So when you should use it? So when you want to clean up your local commit history before pushing it to the GitHub. So that is where you use it. So the key point, always prefer Git reward for changing the changes that have been pushed on the shared remote repository, for maintaining a consistent, linear, clean history for all the collaborators. In short, Git reward is used for shared commits for undoing the changes, and Git reset or Git rebase is used for local commits for rewriting the history in local repository. Question 49. Does Git have built-in branch locking feature? How you can restrict the changes into a branch? So Git does not have a built-in branch locking feature in a way some older centralized version control system might have. So this means Git doesn't natively prevent a developer from pushing to a specific branch simultaneously. So what are the key points? Git distributed nature means developers work on local copies, and directly locking would contradict its model, right? So what are the key points that we can see over here is how to restrict those changes. So we have something called branch protection rules for hosting platforms. So most of the common and effective ways to restrict changes is to branch protection rules, which is offered by Git hosting platforms like Git, GitLab, or Bitbucket. These rules can require pull request before merging, require a certain number of approval before the review is done, require status checks, that is CI/CD builds is been passed or failed, or it will prevent the developers to directly push into certain branches. Or you can make use of hooks on your own GitHub server. You can implement server-side hooks, specifically pre-receive hooks to enforce custom policies and prevent pushes that doesn't meet the certain criteria. Or the team policies, establish clear team conventions and workflow. Example, only the merge via pull request designated specific individual, or merging to a certain branch can be done by a few set of people to manage the access and changes. So in short, Git doesn't have native branch locking strategy, but hosting platform like GitHub have a robust branching approach, that is Git branch protection rules, and server-side hooks for enforcing the branch protection. Now, how do you clone a particular branch in a Git repository? So when you only need to work on a specific branch on a Git repository, you don't want to download the entire history for all the branches. You can use the git clone command with -b or -fin branch flag. So the command would look like git clone -b branch name followed by the repository URL. So here you will replace the branch name with the exact name of the branch that you want to clone, and followed by you will replace the repository URL with the URL of the Git repository. Now this command will create a local copy of the repository, but will only fetch the history of the branch that has been specified by you, and it will check out the branch by default. So you can still fetch the other branch later if needed, but this saves time for initial download, and it will also save the disk space. So use git clone -b to get a local copy of the Git repository focused to a single branch. Question 49, that is, how do you restore a deleted file or a previous change of a file in Git? So basically, Git provides powerful tool to restore deleted file or revert a file in its previous state. The primary command for this is git checkout or git restore for the newer Git versions. So the key command and scenario would be restore a deleted file from the latest commit, restore a file from a specific previous commit, or discard unstaged changes in a file. So git checkout is a versatile command for navigating history and restoring the file. Second, it can always, you have to be careful when restoring, it can override the current changes. So in short, git checkout with appropriate commit reference and a file path to restore the file, or it can be used for reverting the previous state also. Now, how do you list the differences in a file between two different branches? So to compare the content of a specific file between two branches, you can use the getdiff command. This is very useful for understanding how a file has evolved across the different lines of development. So we have getdiff branch 1, branch 2, followed by the path to the file. So here you have to replace the branch 1 and branch 2 with the names of the branch that you want to compare, and replace the file with the relative path of the file that you are interested in. So this output will show you the lines that are the difference between two versions of the file in the specified branches. If you omit file to the path, gitdiff will show you the difference between the two branches. In short, gitdiff branch 1, branch 2 hyphen file will allow you to pinpoint exactly how a file has changed between the two branches, and that is how you will do the things. Now question number 51, how do you list the changes that are going to be fetched from a remote repository without actually fetching them? Without actually downloading and merging them, you can make use of git fetch command without with the hyphen try run option. So the key command will look like git fetch hyphen try run, and the key points here would be this command simultaneously simulates the fetch operation, showing you which branches would be updated and what new commits will be downloaded. Second is, it does not actually modify your local repository or working directory. Third, it is useful for understanding the state of remote repository and planning your next step without making the changes. In short, git fetch hyphen try run lets you safely inspect incoming changes from a remote before actually fetching them. Now, what is git stash and when it is useful? So git stash is a command that allows you to temporarily save changes you have made in your working directory and staging area without committing them. This is incredibly useful when you need to switch contexts quickly without losing your current work. So temporary storage, it takes your modified track file and stage changes and save them into a stack of unfinished changes. It maintains a clean working directory. So after stashing, your working directory becomes clean, matching the head commit, allowing you to switch branches on the work of something that you were doing. Use cases. So when you need to quickly switch from one branch to to fix a bug or check something else, but your current work isn't committed, you can make use of git stash. Now second is pooling updates. If you want to pull changes from a remote repository but have local modification that would might cause conflict, you can make use of git stash. Cleaning up, so to temporarily remove local changes from testing or demonstrate purpose, you can make use of git stash. Now there are following commands that we can make use of, that is git stash save followed by the message. It will save your current changes with an optional message. Git stash list, it will store the list of all the stash changes. Git stash apply, it will reapply most recent stash changes on your working directory. Git stash pop, basically it reapply most recently stash changes and then removes them from the stash list. Google Git repository to a remote repository, that is GitHub, GitLab, or a private server, you make use of git remote add command. This establishes a connection link between the push and pull changes. So what you have to do when you want to connect your local repository with another repository, you run the command git remote add followed by the remote name and the remote URL. Here you have to replace the remote name with short memorable name, that is for the branch, basically the origin. It is commonly used for default primary remote. Secondly, replace the remote URL with the actual repository that is mentioned over here, that is https user/repo.git. So after adding the remote, you can use git push -u remote name followed by the branch name to push your local changes to the remote and for setting up the tracking changes. You can view your configured remotes with git remote -v so that it will show you what are the remotes which is linked with your current local repository. So git remote add create a new connection between a local repository and the remote one, enabling collaboration. Now, what is git ls-tree? Git ls-tree is a git command that allows you to view the content of the object in a git repository. In git, a tree object represents a directory at a specific point in time, listing its file and subdirectories. So what are the key points? Inspect tree object. It helps you to inspect the structure of the components of a directory as a recorded in a commit. SHA1 references, the command takes the tree like commit SHA or branch name and lists all the files and subdirectory it contains along with their mode type. So what are the types of object that we have in Git? Blob, tree, object, all right. So and also it shows the SHA1 hashes. So understanding Git internals. So it uses the it is useful for understanding Git's internal data structure and how it stores your project file in its directories. So git ls tree followed by the tree, that is, it will provide you a way to look inside Git's tree object to see the files and objects folder in a specific commit. What is git cherry pick? So git cherry pick is a command that allows you to selectively apply a single commit from one branch to another instead of rewriting that code again. You can pick a specific commit and apply the changes to your current branch. So it is selective application. It creates a new commit to your branch and duplicates the changes of the chosen commit from the original commit remain in its original branch, but there is a copy that has been added in some another branch. Okay, so where it is useful? So it is useful in hotfixes where you are applying a critical bug fix from development branch directly to release without merging the entire development branch. Second is feature porting, bringing a small isolated feature from one branch to another without full merge. Third is cleanup. Sometimes it is used in conjunction with interactive reviews to move the commits around. So while using a cherry picking can lead duplicate commits and a messy history if overused, especially if the cherry pick commit is later merged normally. And how do you do cherry picking? You need to switch to a new branch where you want to bring the changes, and then you have to write git cherry pick followed by the SHA1 hash. So git cherry pick lets you pick and apply individual commit from one branch to another, useful for isolating the changes like hotfixes. Now, what is git fork? So git fork is oftenly called fork. It is a copy of a repository that exists on a hosting platform like GitHub or Bitbucket. So when you are forking a repository, you create your own independent copy of it under your account. It's a personal copy. A fork is essential for personal copy for someone else's project. Second is independent development. You can make any changes you want in your fork repository without even affecting the original repository. Okay. Now the third is contribution workflow. So the forks are a common way to contribute to open source projects. You fork the project, make the changes, and then submit a pull request. Now, once the pull request is merged, the changes will be reflected in the actual original repository. Third is staying up to date. You can also pull changes from original repository into your fork repository to keep it up to date. In short, fork is a server-side copy of the repository that allows you to freely experiment and contribute it back to the original project through pull request. Now, what is a Git repository? So Git repository is often shortened as repo. It is a central storage location where all the files, folders, and complete history of the project is kept. It is essentially a database that Git uses to track every change made to the file over the time. So it contains all the commit, branches, tags, and metadata that make up the project history. Second is a repository can exist on local computer or on a server side, that is on GitHub. That is .git folder. So the core of Git repository is hidden in .git folder. If you delete the .git folder, it will completely lose its functionality. So .git folder is actually must when you're dealing with a GitHub repository. So yeah, it is necessary for making sure that Git is functioning well, because it is the only folder which maintains the entire Git workflow. Tracking changes. So when you initialize a Git directory, that is Git init, it will create a .git folder to that will help you in tracking the changes and will allow you to do the Git operation. In short, a Git repository is a place where your entire project history is stored, allowing you to manage and track all the changes. Question 58. What is Git squash? So Git squash is a technique used to combine multiple commits into a single or more concise commit. This is oftenly done to clean up a branch history before merging it to the main branch. And it is actually used for making the project history easier to read and understand. Now, what are the key points here? So it is helping you to maintain a consolidated history instead of having many small incremental commits. So example, you have a fixed typo, add button or adding styling. You are actually squashing them into a single one to making a meaningful commit. That is implementing user login feature. So those things can be make use of Git squash. Second is cleaner history. It results in linear and cleaner commit history, which can be beneficial for code reviewers to understand the project evolution. Third is interactive rebase. Squashing is typically performed using interactive rebase. That is git rebase -i. During the rebase, you mark the commits to be squashed or fix up into the preceding commit. So, like git rebase, squashing rewrites the history. Therefore, you should generally only be using it on branch that have not been pushed to the self remote repository. You should use it on the local system. Now, once it is done, then you should be good to go, and then you should push it into a remote repository. So Git squash in total helps you to create a tidy and logical commit history by combining several commits into a single one. Now, question 59, like what is the difference between git fetch, git pull, and git clone? So, git fetch, git pull, and git clone are three fundamental Git commands that are used to interact with the remote repository, but they serve as distinct purpose in how they retrieve and integrate the changes. Okay, what are the key differences between them? So, let us cover about git clone. So, git clone is used to create a local copy of an existing Git repository. It downloads the entire project history, including all the branches and commit, and sets up a local working directory. Second, this is typically the first command that you will use when you are starting to work on a project that already exists remotely. Third, it creates a new directory on your local machine with repository content and initialize the Git tracking. Now, what about git fetch? Now, git fetch is used to download the new data from a remote repository, such as commit, files, references, into your local without integrating your current change into working files. It is non-destructive. It updates your remote tracking branches, but leaves your local working directory with local branch is unchanged. So, it is good for seeing what others have been working on without affecting your current work. Git pull. So it is a convenient command used for fetching the changes from a remote repository and immediately merging them into a local branch. It is essentially for a combination of git fetch followed by git merge. So it can be potentially destructive because it performs a merge and it can introduce conflicts in your local if there is a clash in the incoming changes. You can use it to quickly synchronize your local branch with the remote counterpart, bringing your local copy as a full up-to-date copy with the remote one. So in short, let us cover clone gets a fresh copy, fetch download the changes without applying them, and pull downloads and immediately applies them. Now question number 60, that is what are git hooks? So git hooks are scripts that Git automatically executes after the events like committing, pushing, or receiving. They allow you to automate custom action and enforce policies at various stages of your Git workflow. So the first thing is automation. Hooks can automate your tasks such as running tests, checking code style, sending notification or deploying code. Second is customization. They are a highly customization and can be written in script language like Bash, Python or Ruby. You can also enable a client-side hooks or server-side hook. So client-side hook run on developer's machine. Example including the pre-commit to check the code before committing and post-commit to send notification. Server-side hook to run on Git server. Example include pre-receipt to enforce policy before the push is accepted and post-receipt to trigger deployment or issue the triggers. So location, so the hooks are actually stored in .git/hook directory of your repository. You can find the example script there with the .sample extension where entire thing is been mentioned over here. In short, Git hooks are powerful script to enable automation and policy enforcement throughout the Git workflow, both locally and on the server. Now, question number 61, that is, what are Git tags? So, Git tags are references to the point of a specific point in Git history. They are used to mark important commits such as release points or significant version of your project, providing a stable permanent reference to those commit. So, what are the key points over here? So, first is static references. Unlike branches, tags are static and do not move. Once a tag is created, it always point to the same commit. Second, milestone markers. So they are commonly used as marker for various releases. For example, version 1, version 202, making it very easier to check out a specific version of the code base. So we have two sort of tags, that is lightweight tags and annotated tags. So lightweight tags are simple pointers to commit like branches that never moves. And annotated tags are stored as full objects in the database containing the tagger name, email, date, and tagging message. They are generally used for preferred for releases because they contain more metadata. More metadata meaning more information. So creation tags are typically created after significant commit or often a release is finalized. So how do you create an annotated tag? So git tag -a followed by the name of the tags version 1.0 -m followed by the annotated tag message, that is the version 1.2 release. So in short, Git tags are permanent label for important commits, primary use for marking the releases or significant project milestones. Let us move with question number 62, that is, what is Git aliases? So Git alias is a feature that allows you to create custom shortcuts or abbreviations for Git commands. So by default, by defining aliases in your Git configuration, you can make frequently used or complex Git command easier to fast or for typing. So it is used for shorthand commands. So basically, instead of typing long legit commands like git commit -f amend no edit, you can actually create an alias just like git amend, and that will do the same job. No difference in the working. So it will help you in increasing your efficiency. So aliases save your time by reducing the typing error, specifically for the command that required multiple option of flags. That is customization. You can define aliases for almost any Git command or sequence of the commands. Configuration. Aliases are actually stored in your Git configuration file, which are present in .git config file. Okay. So let's say if you want to create the alias for status, that is Git status, you can make the alias for st, which is equivalent for status. So how would your command look like? It will be like git st, but in backend it will run the command git status, right? So this is how Git aliases work. So Git aliases are personalized shortcuts for Git commands, which are used for improvising your efficiency and making your command line workflow very much smoother. Okay, that was all. Let us move with the next question, that is question number 63. What is Git GC? Git GC stands for Git Garbage Collection. So it is a Git command used to optimize and clean up your local Git repository. Its primary purpose is to remove unnecessary files and data that are no longer needed. So basically, it is also used for compressing objects and generally used to improve repository performance and disk usage. What are the key points over here? It packs loose object into a packed file, making the repository more efficient to store transfer. Secondly, it removes unreachable objects, data that is no longer referenced by any commit message, branch or tag, and that are older than a certain threshold. It automatically is used for the execution. Git often runs Git GC in the background after operations like git commit or git merge. if it detects that the repository could benefit from the cleanup. So manual execution, you can also run it manually if you notice the repository is getting large or slow. So the command is git gc. It is Git's built-in maintenance tool for keeping your repository lean and fast by cleaning up old and redundant data. Now we learned about Git GC. Then what is Git GC aggressive? So it is an option used with Git GC command to perform a more thorough and aggressive garbage collection on your Git repository. When Git garbage collector runs automatically and performs basic cleanup, aggressive flags will tell you to work harder to optimize their repository. Okay. So it is used for more intensive optimization. It performs more extensive repacking of object, which can lead to smaller repository size. That is the benefit of Git GC hyphen aggressive. Longer execution type, because it doesn't does more work. Aggressive can take significantly long time to run and consume more system resources compared to the regular Git GC command. So it is typically used when Git repository has become very large or slow and you need to reclaim as much disk space as possible or improvise a performance sustainability. It's not usually run as a part of routine maintenance. So due to its resource intensive nature, it's generally not recommended for frequent use or for very active repository without careful consideration. So the command is git gc -f aggressive. It is powerful but a resource intensive command for deep optimization and cleanup for Git repository. Best use sparingly when significant reduction or performance improvement is actually needed. Now, what does the .git folder contain? Okay, this is the standard question which we should know. So it is the heart of Git repository. It has hidden files that contains all the necessary information and the metadata for Git tracking and manage your project's version history. First is object. The directory shows all the actual content of your project, that is files, directory, commit in highly compressed and efficient format. These are the fundamental building blocks as in objects, that is blobs, tree, commits. Okay. Second is references. It contains pointers to commits specifically for the branches. And head and text contains the header and the tag. These are simplified files that store the SHA-1 hash of the commit that they point to. Now, a head, it is a file that points to the current branch or the commit that you are working on. Config, the repository specific configuration file containing the settings like remote URLs, branching and tracking information, and user details of the particular repository. Hooks, so it contains the script that get execute automatically before and after certain events are been done. For example, pre-commit suit and post-commit hooks. Second is index or the staging area. It is a binary file that stores the information about the file in your working directory that are staged for the next commit. So in short, .git folder is where you store everything that need to manage the Git project history, from file contents, from branch pointers to the configuration settings. Now, what is bare Git repository? A bare Git repository is a special type of Git repository that does not have a working directory, unlike regular repository where you have your project file and a hidden .git folder. Bare repository only contains the .git folder itself. So no working directory, meaning there are no actual files, source code or project. It only contains the version history and configuration information. Centralized storage, bare repository are primarily used as central shared repository. Developers own them and push to them and pull them. Collaboration hub, it acts as a hub for multiple developers to exchange changes without anyone directly working within the bare repository itself. Naming convention, bare repositories are typically named with .git suffix. Example, my project.git. In short, a bare Git repository is a server-side repository that only stores the Git history, serving as a central point for team collaboration without a local working copy. Now, what is a Git remote repository? It is a version of your project that lives on the server or other the location outside your local machine. It serves as a central point of collaboration, allowing multiple users to contribute to the same project and sharing their changes. Now, remote repositories are essential for team-based development, enabling developers to push their local changes and pull updates from others. They provide a backup of your project history, protecting against your local data loss. Now, hosting platform, common hosting platform here are GitHub, GitLab, Bitbucket, and Azure DevOps. Now, origin, the default name for the remote repository that you can clone is usually origin. Interaction, basically you interact with the remote repository using command like git clone, git fetch, or git pull. In short, Git remote repository is a shared external copy of a project that facilitates a collaboration, backup, synchronization among the team. Now, what is working tree in Git? So, working tree in Git is also known as work dir. In Git, it is a directory on your local file where you are actively working on your project. It contains the actual file and the actual folder that you can modify, edit, and use. It's your personal workspace where you make the changes to the project. The working tree reflects the state of the project as the current checked out branch or commit. Any modification you make in the working tree are initially untracked by Git until you are explicitly adding them to the staging area. It is separated from .git. That is, it's a distinction from the hidden .git directory, which contains all the repository history and metadata. In short, working tree is where you interact with your project file directly, making and seeing the changes before they are tracked or committed by Git. Now, what are the typical roles and responsibility in a Git project? In a collaborative Git project, various roles are often defined to ensure smooth workflow, code quality, and efficient project management. While specific titles may vary, the responsibility generally follow in these categories. So, what are the roles and responsibility for developers and contributors? The responsibilities are writing code, creating new feature, fixing bug, committing the changes to the local, and submitting pull requests for review. Their focus is individual code development, ensuring that the changes are integrated well with the project. When it comes to reviewers, so their responsibility would be to examine the pull request from other developers, providing the feedback, suggesting the improvements, and approving the changes before they are merged into the main branch. So their focus would be code quality and adhering the coding standard and preventing bugs. Now, maintainers or project leads. So responsibilities are overseeing the overall health of the repository, managing the main branches, that is main develop, merging the approved request, resolving the complex conflict, and setting project directions. Their focus are project architecture, stability, and ensuring the code base remains the consistent and functional. Release manager. So their responsibilities are coordinating the software releases, creating tags for stable version, managing release branches, and often overseeing deployment process. So their focus are mostly into delivering stable and tested version to the users. So in short, Git project involves developers creating code, reviewers for ensuring quality, maintainers to guiding the project, and release manager for handling the software delivery. Question 70. What port does Git typically use for communication? So Git itself doesn't directly use network ports in the same way a web server does. Instead, it relies on underlying network protocol to communicate with Git remote repositories. The ports used depend on the protocol configured to the remote. First is SSH. The port number here is 22, often used for secure authentication access for remote repository, especially for pushing the changes. It requires SSH key for authentication. Next is HTTPS, that is port number 443, commonly used for cloning and fetching. It can also be used for pushing. Authentication is typically done by username and password or personal access tokens. Third is Git protocol, that is 9418, which is default by default it comes. So a dedicated Git protocol that is very fast but unauthenticated. It's primarily used for anonymous read-only access, cloning the public repository. So this is the link that you will see. So Git uses associated underlying protocols like SSH port number 22, HTTPS port number 443, or Git protocol that is 9481 for remote communication. Question 71. How do you check all remote branches and get them locally? To effectively manage your project it's a crucial way to know what branch exists on remote repository and how to bring them into your local environment. This involves fetching and then checking out. So first would be to fetch all the remote branch. Second is to list them, and third is to create new local branch from remote tracking branches and then switch to it. So in short, you use git fetch -f all to get all the remote branch info, then -r to see them, and finally git check on -b to create and switch to the local tracking branch. How do you merge two Git repository? Merging two separate Git repository in one can be complex task, but it is achievable by treating one repository as a remote and other as the merging point. The first thing would be you have to clone the repository. This will be your primary repository. Second, add the second repository as remote. Fetch the content of the second repository, merge the history, resolve the config if there are any, and then push the merged repository again. So to merge repository, you need to add one as remote and other as fetch the content, and then merge the history, and then make sure you are allowing all the history, and then you are pushing it back to the server. Question number 73. That is, what is git bisect? Git bisect is a powerful command that is used for finding specific commit that introduced a bug or regression in your code. It performs binary search on your commit and help you to quickly pinpoint the problematic commit. Okay. Now, what are the key points? Binary search. It automates the process of checking out the commits to find where the bug was introduced. You start by telling it's a good commit where the bug didn't exist and a bad commit where the bug exists. Git bisect will then check out a commit halfway between the good and bad commit. You test the bug and then you will tell whether it is a good commit or a bad commit. Narrowing down. Git continues this process narrowing down the range of commit until it identifies the exact commit where the bug was first appeared. This is much faster than manual checking out each commit one by one. So basically, when you do git bisect start, okay, it will mark the specific commit as bad, and then once it found a good commit, it is marked as a good commit. Git check out a commit, then you test it, then you bisect it good, and then it is used for the bisection. Git bisection is a debugging tool that uses binary search for effectively finding the commit that introduced a bug. Now, what is a blob in Git? A blob is a binary large object. It is one of the fundamental object type in Git. It is used to store the content of a file at a specific state without any metadata like file name or file path or permission. File content, a blob object simply holds the raw data of file. If two files, like two versions of the same file have identical content, it stores only one blob object for them. Each blob has identified by a SHA-1 hash, which is used for which is calculated based on its content, and it ensures data integration and efficiency has been done. Blob does not contain information about the file name, directory structure, or permission. This is the metadata stored in the tree object. Once created, a blob cannot be changed. If a file content change, a new blob has been created. In short, blob is a Git's way of storing actual content of the file, identifying its content hash, and it's a core component of Git's object storage. Question number 76. What is git blame? So git blame in git command shows the author and the most recent change of for each line in file. It is a powerful tool for understanding Git's history file line by line, helping to identify who made a particular change and when it was made. So for each line in a file, git blame displays a commit SHA and the author and the timestamp of the last commit that has been modified at the specific line. It's incredibly useful for debugging, and it's help you to trace when the particular line was introduced or changed and by whom it was done. This can be crucial for understanding why the bug might exist or for asking the right person for the right context. So understanding the code evolution, so it provides insight about the evolution of the individual line of code, which can be helpful during the code reviews or when we are refactoring the old code. So this is the command git blame followed by the file path. It helps you to understand the history of each line in a command, showing who was the last person who modified it and when it was modified, and what is invaluable for debugging and code comprehension. Last question. What are Git webhooks? Git webhooks are automated HTTP callbacks or small programs that are triggered by specific events in Git repository, typically hosted on Git platforms like GitHub, GitLab, Bitbucket. They allow you to automate actions on integrating external services with your Git workflow. So it is event driven. Webhooks are activated when a predefined event occurs in the repositories, such as pushing a code to a branch, creating a pull request, or merging the change in that specific branch, or a comment that has been added. So when an event happens, the Git hosting platform sends an HTTP post request to the configured URL. This request contains a payload that of the data that is actually describing the event. Second, integration. Webhooks are commonly used to integrate with Git with other tools service such as GCD pipeline. So it is used to trigger a pipeline. So triggering a build test process on a continuous CI/CD, that is Jenkins or Travis CI. Whenever a code is pushed, it will act as a triggering point. Second, notification. It is used for sending message to the chat application like Slack or Microsoft Teams when certain events occur. Third is project management. Updating status task in a project management tools such as Jira or Trello. It can be done with the GitHub Webhooks. The fourth one would be deployment, automatically deploying a code after a successful merge to a production branch has been done. So in short, Git webhooks are a mechanism for Git hosting platform for notifying external services about the repository events, enabling powerful automation and integration workflow. So yeah, that was all. We have covered a lot of question today, and yeah, that was all. And I hope you have learned what can be done with Git and what are the things that Git offers. So yeah, that was all, and I will